Good morning, everyone. So today we are going to study solutions of say physics paper, which is say held this year only in February month, 1st of Feb, and that is of say morning shift. So this morning shift paper we are going to study. So in this paper, physics paper, JEE Main, this is a JEE Main 2023. First Feb morning session paper, physics. So for this, you will see that the first question. So this first question consists of say average kinetic energy. So it deals with say, average kinetic energy of a molecule of the gas. So average kinetic energy of a molecule depends on the degree of freedom and temperature of the body, and that equals to say F by 2 times say kBT. So this will say average kinetic energy, and it will be directly proportional to temperature also. So absolute temperature. So that's why option 1 will be correct. In second question, this is accretion region question. First statement is that accretion due to gravity is different at different places on the surface of, which is true because accretion due to gravity at different places of Earth varies due to several reasons. That is say due to latitude angle, due to say non-sphericity of Earth, due to say rotation of Earth. So due to these regions, accretion due to gravity differ at different places. It is for statement 2, it is seen that as we go down below the Earth's surface, accretion due to gravity decreases with the depth. And it says that increases. That's why statement 2 will be false. So statement 2 is false and statement 1 is true. So option 2 will be correct because accretion due to gravity decreases as we go down below the Earth's surface. So second option will be correct. Moreover, question number 3. This is a unit and dimension questions, and in this question, we see that there is a van der Waals equation given: pressure plus AB square V minus B equals to RT for some gases, and P is pressure where V is volume and T is temperature. So we have to find V square by A. So but we see that by the principle of homogeneity, similar terms are added with similar terms. That's why dimension of B will be that of say one dimension of volume, that is say L cube. And similarly, dimension of this A by B square will be dimension of pressure P. And from here, we say that dimension A will be say pressure into this volume square will come here, V square. So pressure dimension is say M1, L minus 1, T minus 2, and volume square is say L cube dimension. So it will complete ultimately M1, L power 5, T minus 2, that is the dimension of A. And dimension of B is that is a L cube volume. So B square by A dimension we have to see. So B square by A dimension will be say volume cube that square, that is say L6, and then dimension of A that is say M1, M minus 1, L raised to power 1, and time dimension is 2. So here mass is dimension is minus 1, length dimension is 1, and dimension of time we have to take 2 for this B square by A. Now compressibility is defined as reciprocal of bulk modulus, and bulk modulus is dimension is same as that of pressure, that is say ML minus 1 T minus 2. So here is the dimension of pressure, and from here dimension of compressibility will be M minus 1 L1 T square. So this is the dimension of compressibility. We see that dimension of B square by A from here and dimension of compressibility from here, these two are equal. So these two will be equal. So that's why option 2 will be correct. So for this, option 2 is correct. This is a third question. In fourth question, we see that there are say several So we see that there is a straight line in which three different speeds are given. So in this straight line, say this is say A, B, C, and D. 4 points are there, positions in a straight line, and A, B, and B, C are equal, and AD is say 3 times AB. So from where we can see that A to D will A to B will be D, B to C will be D, and C to D will be D. So from where we get that AD equals to 3 times AB. So by calculation, we see that AB, BC, and CD are of equal distance D. So D is a distance. So D is a distance. So for average speed, we have to see total distance covered by the particle. So that will be obviously 3D, and time taken by the particle to cover this individual speed. In first part, speed is v1. In second part, we see speed is v2, and the third part, speed is v3. The first part is time will we say dy v1, second part dy v2, and third part dy v3. So this average speed will be 3 times v1, v2, v3 divided by sum of these two. That is say v1, v2, v2, v3, and v3, v1. So this will say average speed. So this gives average speed. So option 4 is correct. So for this, we can say option 4 is correct. Question 5th. Here there are say two thin plates, infinite thin plate sheets are there. An electric field in 3 different regions. 1, region 2, and region 3 we have to find. So what we see that surface charge density is sigma is same for both the plates. So for first region, electric field due to this first plate will be towards left and sigma by 2 epsilon. And here for second plate, electric field will be in the same direction, leftward, sigma by 2 epsilon. So these are say electric field due to these two plates. Then between these two plates, first plate will have electric field in right direction, and the second plate will be the electric field in left direction, which opposes each other. And in the third region, electric field due to both the charges adds, so add up. ये दोनों add होते हैं. Now we see that if we consider this direction as n cap, so if we consider n cap as the normal unit vector in say right direction, so for this E1 vector will be sum of these two. So sum of these two. E1 will be sum of these two, and it will say towards negative direction, minus n cap direction. So direction will be minus n cap, and 20 will be negative, and it will be sigma by epsilon naught n cap. In second region, these two fields cancel each other. It will be a null vector. In the third region, electric field of these two are added. So electric field of these two are added. And it will be sigma by epsilon naught in right direction. So it will be sigma by epsilon naught n cap. So option 3rd is correct. So here it should have some null vector here. So we should write this as null vector. So assuming that this 0 is represent null vector. Question number 6. In this question, a mercury drop is broken into 125 equal size droplets. So it loses some energy. So it gains some energy. So there will be some gain in energy. So for this, suppose the single drop mercury has radius r. Now this volume of this mercury drop will be split into say 125 drops of say a volume 4 pi by 3 r cube. So from here we see that this tiny droplets has a radius r by 5, that is say 2 into 10 power minus 4 meter. Now we see that a single drop of say radius r is say split into 125 tiny drops, and each have say radius r. So radius of each drop has radius is r. So we see that if surface energy of this bigger drop is say initial energy, that will be say sigma into surface area, that is 4 pi r square. This will be the surface energy of initial, and this surface energy final will be of say 125 droplets, and radius will be say smaller. So this will be sigma into 4 pi square. This is the surface energy final and initial. We will take these two difference. Sigma is say surface tension, and that is given as say 0.45. So 0.45 Newton per meter is the surface tension, and then we will put the values. It comes out 2.26 into 10 power minus 5 joule. Question number 6. So option 4 is correct. So option 4 will be correct option. In question number 7, a proton moving with 1/10 of velocity of light has a certain de Broglie wavelength of lambda. An alpha particle having certain kinetic energy has the same de Broglie wavelength lambda. The ratio of kinetic energy of proton and that of alpha particle is. So we have to find kinetic energy. We see that as the wavelength of their motions are same wavelength, de Broglie wavelength. That means moment both has same momentum. So momentum will be same h by lambda for both. And kinetic energy of a particle is defined as p square by 2m, where p is momentum. So if we take ratio of kinetic energy of proton to the kinetic energy of alpha particle, so kinetic energy of proton will be momentum square divided by twice of mass of proton, and kinetic energy of alpha particle will be momentum square divided by twice of mass of alpha particle. So it will be ratio of say mass of alpha and mass of proton. Alpha mass is 4 mu and proton mass is 1 mu. It will be ratio 4:1. So 4:1 will be ratio. This will say kinetic energy ratio. So option 2 is correct for 7th. In question number 8, this is a column matching question. In list 1 consists a intrinsic semiconductor, then n-type, p-type semiconductor and metals, and list 2 contains Fermi level, which is say so that we near valence band, near conduction band, yeah, say in middle of these two. So we have to match these columns. So for this, if we see that in an intrinsic semiconductor, some doping is done, and due to this, between say conduction band and valence band, an intermediate Fermi level is developed. So here intermediate Fermi level will be developed. That's why in intrinsic semiconductor, Fermi level in middle of valence and conduction band will be there. That is say option 2. So A has option 2. Next, for n-type semiconductor, doping is done having say excess electrons. So that's causes donor energy level, that is a Fermi level closer to conduction band. So for this B n-type near say conduction band, that means will be say third option. So B will have third option, third choice. Then for p-type, doping is done so that holes are created, and these holes are created nearer to the valence band. So it is say near the valence band. So this p-type will option 1. Then for metals, these two overlap. So these two conduction band and valence band overlap. So we can say ki Fermi level is inside the conduction band. So that's why for metal for D option 4 is correct. So third option is suitable, best option for this question. So option 3 is correct. Question number 8. Next, question number 9. Question number 9 says that which of the following frequency does not belong to FM broadcast? So for FM broadcast, the range of frequency varies from 88 megahertz to 108 megahertz, and this 64 megahertz is out of this range of frequency for FM. So that's why it doesn't belong to this FM broadcast. So this first option, 64 megahertz, will be correct option. Question number 10. A block of mass 5 kg is placed at rest on a table of rough surface. Now, if a force of 30 Newton is applied in the direction parallel to surface of the table, the block slides through a distance of 50 meters in an interval of time 10 seconds. Coefficient of kinetic friction is given G equals to 10 meter per second square. So we have to find coefficient of kinetic friction. For this, displacement is given as, say, distance covered is, say, 50 meter and in a time interval of, say, 10 seconds. So displacement will be, say, half at square. Initial it is at, say, rest. From here, we will put displacement as 50 and time we will put 10 seconds. And from here, acceleration comes out 1 meter per second square. Now this block has acceleration in right direction, that is, say, 1 meter per second square. And in the rear direction, we are applying some force, 30 Newton. So 30 Newton force is applied on this block, and a friction force opposes this motion, and it will say mu q mg kinetic friction. So from here, we see that for this 5 kg mass, Newton's second law is that net force will be equals to mass into acceleration. So this net force is, say, 30 applied in the direction of acceleration minus kinetic friction mu q mg, and that will equals to, say, mass into acceleration. From here, this is, say, 30 and mg is the mass into g, that is, say, 50. Mass is, say, 5, acceleration is 1, and from here mu k is, say, 0.5. So this mu k comes out 0.50. So option 4 is correct. So option 4 is correct. Question number 11th. A steel wire with mass per unit length 7 into 10 power minus 3 kg per meter is under tension of 70 Newton. The speed of transverse wave in the wire will be. So we have to find speed of transverse wave. So we have to use wave speed in a string as formula under root T by mu. So we will use a square root of, say, T and tension and linear mass density mu. Tension is given as, say, 70 and linear mass density is given as, say, 7 into 10 power minus 3, and from here it comes out 100 meter per second. So option 1 is correct for 11th. In question number 12, the mass of proton, neutron, and helium nucleus are respectively 1.0073 U unit, 1.0087 mu unit, and 4.0015 unit for helium. The binding energy of helium nucleus is, so we have to find binding energy. For binding energy, we know that there is some mass defect, that is, say, delta m, and multiplied by speed of light square, that gives the binding energy. Mass defect depends on the mass of constituent particles, which is, say, proton and neutron, and mass of the product, which is, say, helium nucleus. We see that 2 proton and 2 neutron merge together to become nucleus of helium. We see that twice of mass of proton and twice of mass of neutron sum, this is, say, greater than nucleus mass. So this excess energy is called binding energy, which is, say, released. So this binding energy is the mass defect into c square. So this will say twice of mass of proton. So mass of proton is, say, 1.0073 and mass of neutron 1.0087. And we will subtract mass of helium, that is, 4.0015 multiplied by c square. If we replace the c square by, say, in energy terms, we have to write mega electron volt. So it is multiplied with 931.5 mega electron volt, because we know that 1 mu into c square is 931.5 mega electron volt. So from this relation, mass difference comes out 0.0305 mu multiplied by this 931.5 mega electron volt. So that will give 28.4 mega electron volt. So this first option is correct. Question number 12. First option is correct. In question number 13, a sample of gas at temperature T is adiabatically expanded to double its volume. The work done by the gas in the process is. So since this is a expansion, volume is increasing, that's why this work will be positive, and this work will be given by nr delta T divided by gamma minus 1 for an adiabatic process. Here we have to find final temperature. Initial temperature is given. For this, we will use TV gamma minus 1 equals to constant, which is say adiabatic equation. From here, we see that temperature final and temperature initial ratio will be volume initial, volume final to the power gamma minus 1. Volume final is say half of this, and gamma is given as say 3 by 2, so it will be say half. So it will comes out 1 by root 2. So from here, we get that temperature final is initial temperature by root 2. Now work done is given by formula. Work done is say for adiabatic process, work done is say minus delta U, change in internal energy, and that comes out nr delta T divided by gamma minus 1. From here, we see that if we take 1 mole of gas, so it will be say R times delta T, matlab that means T final, T initial divided by gamma values. For gamma values say 3 by 2 minus 1, that is say half. So it will be say 2R times temperature final, that is say T by root 2, temperature initial, that is say T. So ultimately, this work will come out say RT 2 minus root 2. So this work will come out RT times 2 minus root 2. Here we are assume that number of mole is 1. So for 1 mole of gas, this option 4 is correct. So for this option 4 is correct. In question number 14, a child stands on the edge of the cliff 10 meters above the ground and throws a stone hurriedly with an initial speed of 5 meters per second. Neglect the air extent, the speed with which the stone hits the ground will be how much meter per second? G equals to 10 meter per second square. So for this question, we have to see that this is a horizontal projectile where say initial speed is say given as say 5 meter per second. When it strikes the ground, it has say horizontal velocity, that is say 5 meter per second, and vertical velocity also. So this horizontal velocity is say 5 meter per second, and this vertical velocity is given as say root 2 gs, because we know that Vy square equals to Uy square plus twice Ay h. From here, Vy will be say under root 2 gh as Uy is 0. So this initial velocity in y direction is taken as 0. So Vy is under root 2 gh. And this comes out, its value, height is given as say 10 meter. So its value will be say 200 meter per second root, that is say 10 root 2 meter per second. Now speed of the particle will be given as say v, which is say resultant of x component of projectile and y component of projectile. So this speed v will be say root of x square, that means 25, and Vy square, that is say 200 meter per second, it comes out 15 meter per second. So option 1 is correct. So for this, option 1 is correct. Question number 14. Next, for question number 15, we see that klystron valves is used in ovens to generate microwaves, and gamma rays are emitted in every radioactive decay of a nucleus. From inertial electrons are removed when bombarded in a target, and X-rays are emitted. So this third D option will match with third. This microwave option matches with klystron, that is say fourth. Then this B gamma rays matches with first, and this third C option radio waves. In radio waves, electrons are excited and decelerated, and waves are generated. That is a radio waves. So this is say second. So for this, option fourth is correct. So this option 4 will be a correct option. Question number 16. Find the magnetic field at the point P in figure. The curved portion is the same circle connected to two long straight wires. So here, a semi-infinite wires. So two semi-infinite wires. This one first, and then this vertical down. This one, and then this semicircular wire. So three wires are given. We have to find magnetic field at point P. For this, we will say. So we will consider these as say three different wires. So we will consider these as say three different wires, and all these wires will have some magnetic field. For this first wire, this is say second, and this is say third wire. So magnetic field at point P will be say vector sum of this fields of these three wires. So field of first wire, then field of second wire, and then this a field of third wire. Now this field of first wire will be say mu naught I and then 4R, and it is directed say inward. So it is directed say outward. So it will be say directed outward. In the second wire, this is with and this first wire is say this is basically a semi-infinite wire. So it will be 4 pi R. The second wire is a semicircle, so it will say mu naught I by 4R magnetic field, and it is again outward. And this third wire has zero field, because this point P lies on this, on the line on this wire, points extended on this wire. So it contributes a zero field. So this third wire doesn't contribute some field. So it will be net field will be say mu naught I divided by say 2R, that is say 1 by 2 pi plus half, and which is outward, which is nothing but say third option. So option third will be correct. So for this option third will be correct. in question number 17. So this is again say column matching question, where this list one consists of say first A part AC generator, B part transformer, C part resonance phenomenon to occur, and D part sharpness of resonance. List two consists of say first part presence of both L and C, second part electromagnetic induction, list two third part quality factor, and list two fourth part mutual induction. So we have to match the columns. For AC generation, we see that it works on principle of say for first option, we see this AC generation depends on say electromagnetic induction. So for AC generator, so for AC generator, electromagnetic induction, EMI principle of electromagnetic induction works. It works on principle of electromagnetic induction. For this B part transformer, so this transformer also works on electromagnetic induction, but in this case, mutual inductance happens in between say secondary and primary coils. So or say primary or secondary coils. So there is a mutual induction. So this fourth option will be correct option. For list one C part, resonance, for resonance to occur, there should be say LC oscillation. So LC oscillation may have some resonance. So LC oscillation, so its circuit should be say LCR circuit. Circuit should be LCR. For resonance, resonance frequency is say 1 by root LC. So that means inductor and capacitor are needed. So this C option will have first, and then for this sharpness of resonance. So for sharpness of resonance, quality factor defines the sharpness. So this sharpness is defined by quality factor. So it will be related with third option. So from here, option 2 matches. So for this, option 2 is correct option. Sharpness of resonance. So for sharpness of the quality factor is defined sharpness of resonance. So option 2 is correct. Question 17. In question 18, this question is of say polarizing sheet, and polarizing sheets are arranged such that each makes an angle 45 degrees with the preceding a sheet. An unpolarized light of intensity I is incident into this arrangement. The output intensity is found to be I by 64. The value of N will be. So for this option, we see that if there is some polarizer, and this is say pass axis. So this vertical is say pass axis. So if this vertical line is say pass axis, and if there is say some wave which is say falling at certain angle theta with this pass axis, then if this wave has initially intensity I naught, then the intensity we get as say I naught cos square theta, average intensity. This is called say Malus law. So according to this Malus law, we get this intensity. Now this intensity I is repeated. So this they say for 45 degree angle, it will say cos square 45 degree. Then this resultant intensity again pass through 45 degree next polarizer. Then it is passed through 45 degree next polarizer, and it is say up to n times. So there are say n shifts. So this intensity I will be say initial intensity multiplied by cos square 45 degree raised to the power n. That means intensity I will be say I naught divided by 2 power n, and from according to question, this intensity is I is say initial intensity divided by 64 times. So if we consider say initial intensity as say I naught, then it will be say I naught by 64. So from here we get that 2 to the power n equals to 64, and we see that n power 6, so n should be 6, so 6 sets should be used. So option 4 is correct. So for this option 4 is correct. Question 19. If Earth has a mass 9 times and radius twice to that of a planet P, so this is a gravitation question, then V upon 3 root x meter per second will be the minimum velocity required by a rocket to pull out of gravitational force of P, where V is escape velocity on Earth. The value of x is. So in this question, escape velocity of Earth formula has root 2gm by radius of Earth, where say g is gravitational constant, m is the mass of Earth. Now this mass of planet is m by 9 times mass of Earth divided by 9, and this radius of planet is half of radius of Earth. So escape velocity for this planet will be twice the mass of planet divided by radius of planet and root, which ultimately comes out twice of g mass by radius, and this radius is r by 2, 2 will come out upward, and then it will be divided by 9. So ultimately we get that velocity of planet, escape velocity at planet will be say root 2 by 3 times under root of 2 gm by r. So it will be say root 2 by 3 times velocity of escape velocity on Earth. For this question, this planet velocity is given as say root x by 3 VE. So from here we comparing, we get x equal to 2. So option 1 is correct. So this option 1 is correct for this 19th question. So for this 19th question, option 1 is correct. Question number 20. The equivalent resistance between A and B of the network shown in figure. Here we see that it is a say Wheatstone bridge having say 5 resistances. So if we draw Wheatstone bridge, so we see that it will be a balance of Wheatstone bridge. So equivalent resistance between A and B of the network shown, we have to find where a Wheatstone network is given with resistance R, 2R, then middle one is a 9R, then 3R and 6R, and we have to find resistance across AB. For this, we will redraw this circuit, and we will make a balanced Wheatstone network. We see that ratio of this R and 2R and 3R and 6R are equal. That means it is a balanced Wheatstone. That's why no current will pass through this resistance 9R if we connect with it with a cell. So if we supply some source we across AB, then 9R will have no current. So that's why 9R will be removed and circuit will become this one. So this will be the circuit. In this resistance across AB, we see that R and 3R are in series and 2R and 6R are in series, and these two are parallel to each other. So we see that R plus 3R, that is say R plus 3R is parallel with say 2R plus 6R. That means this 4R is parallel with 8R. So it will be say 4R into 8R divided by 12R. So it will be say 8 by 3R. So this option 2 is correct. So this solution 2 is correct. Now these questions are say fill in the blanks question, numerous type questions where we have to find numerical values. And for this question number 21st, in this question, two equal positive point charges are separated by a distance 2a. The distance of a point from the center of the line joining two charges on the equatorial line, that is say perpendicular bisector, at which force experienced by a test charge Q0 becomes maximum, is A upon root x. The value of x is. So we have to find value of x. So this force is maximum on Q0 when its distance is A upon root x from midpoint. So we see that there are say 2 point charges QH and separated by distance 2a. So there will be a perpendicular bisector. So this will be a perpendicular bisector passing through this midpoint, and at a certain height y. So at a certain height y, we will put some charge Q0, and this at the ends two charges Q each are there. Now distance between mid and charge Q is say a, and this perpendicular is y. So this hypotenuse will be Pythagoras theorem root a square plus 0. So distance between charge Q and Q0 will be root of this by Pythagoras theorem, and here also Q and Q0. Now this Q0 is placed at a height y, and two forces are applied by these two charges. So Q charge applies this force F in this direction, and this Q charge applies force F in left direction. And we will see that resultant force on this Q0 due to these two charges will be along this direction, that is say 2f cos theta. So this F, suppose we are making this angle theta with vertical lines. So by geometry, these two are say crossed. So these angles, all these four angles will be equal. So this is say theta angles. Now this F cos theta is added this direction. Then this F cos theta of this is again added this direction. So total force will be 2F cos theta. And this F sin theta is cancelled out. The F sin theta component is cancelled out. So this resultant force we will get due to these two forces F and F by say Q and Q will be say 2F cos theta, where F is force between Q and Q0. So that will you say 1 upon 4 pi epsilon naught Q0 divided by distance square, that is say this hypotenuse square. Net force will be 2F cos theta. So this is say net force. So this net force will be say 2F cos theta. Now here we will put values of say F here, and then value of cos theta. So it will be say Q0 by 2 pi epsilon naught multiplied by 1 upon root of 1 upon say a square plus b squared sum, and then multiplied with cos theta. Cos theta values say in this triangle, cos theta values say y upon this hypotenuse. So y upon this hypotenuse root a square plus b square. From this f net comes out Q0 by 2 pi epsilon naught multiplied by this y divided by a square plus b square raised to the power, the whole is raised with the power 3 by 2. So this is say F net. This is the net force on Q0 due to these two charges. Now we have to find at what y, at what height y, this force will be maximum, net force. So for net force to be maximum, differentiation of this net force with y must be 0 for maximum of F0. That means this constant QQ naught by 2 pi epsilon naught is a constant. This is say kept outside. Then we will apply this U by V formula, quotient formula for differentiation, and we will take this square. This is a square. Then we will keep it and we will differentiate y, that is say 1. It is say multiplied by 1. Then we will keep y as it is and we will differentiate this denominator 3 by 2. 3 by 2 has differentiation as 3 by 2 power rule. We will apply a square plus y square. Then power chain rule we will apply inside differentiation also. For this term, differentiation is 2y. So after differentiating this and putting 0, we are getting that this root term is kept outside. So this power will become 5 by 2. And here we will get a plus y square minus this 2 is cancelled out, 3y square. This root is kept outside, 3y square. From here we get that this cannot be 0. So we will keep this as 0. And from here a square is set 2y square. And from here y equals to plus minus a by root 2. That means at a distance a by root 2 above and at a distance minus a by root 2 below, at both these points force will be maximum in magnitude. So for this a by root 2, that means here x will be 2. So this x will be 2. So for this x value is 2. Question number 22. In question number 22, a light of energy 12.75 electron volts is incident on a haded atom in its ground state. The atom absorbs the radiation and reaches to one of its excited states. The angular momentum of the atom in the excited state is x upon pi into 10 power minus 17 electron volt second. The value of x is, use h equal to, h is a Planck constant, 4.14 into 10 power minus 15 electron volt second, and speed of light c equals to 3 to 10 power 8 meter per second. So for this question, we see that ground state energy is say 13.6 electron volt and first state energy is 3.4 electron volt. That difference is say 10.2 electron volt for first excited state. So for first excited state electron, its energy needed is say 10.2 electron volt. For second excited electron, this is we have to subtract second energy level, energy of second state, energy of say third state, and it comes out say 12.09 electron volt. For second excited state. Now this 13.6 electron volt minus 0.85 electron volt. So this is exact 10.75 electron volt, and this is for third excited state electron. That means third excited state, that means n equals to 4. So n will be 4. Or we can solve it by just 13.6 electron volt minus 13.6 electron volt by n square. Difference should be 12.75 electron volt. From here, we get n equals to, n square is 16 and n equals to 4. So this is say third excited state, that is say n equal to 4. So this angular momentum L will be say nh by 2 pi, that will be say 4 by 2 pi multiplied by h. That means say 2 by pi into h value. H value say 4.14 into 10 power minus 15 electron volt second. So ultimately its value is say 828 by pi into 10 power minus 17 electron volt second. So from here, this x comes out 828. So value of this x is 828. So 828 will be answer. Question 22. Question 23rd. In an experiment to find EMF of a cell using a potentiometer, the length of null point for a cell of EMF 1.5 volt is found to be 60 centimeter. If this cell is replaced by another cell of EMF E, the length of null point increases by 40 centimeter. The value of E is x by 10 volt. The value of x is. So we have to find unknown shell EMF E. For this, if phi is say potential gradient, so if we take phi as potential gradient, then we know that at null deflection, this phi L will be EMF of the shell used. So L is called balancing length. For this, phi L2, so this E2 will be phi L2 and this E1 will be phi L1. From this, taking this to ratio, E2 by E1 will be say L2 by L1. Here, E2 is say E and E1 is say 1.5 volt. L2 is say 60 plus 40 and L1 is say initial balancing length, that is say 60. So it comes out say 10 by 6, that means say 5 by 3. So from here this E equals to 2.5 volt, that is say 25 by 10 volt, which is nothing but x by 10 volt. So from here x is 25. So its answer will be 25. So answer is 25. So in a potentiometer, so some shell is used, and then here another here some cell is used, and this file is say potential gradient, and certain galvanometer is also used for null deflection. So for null deflection, Ig is 0 and this phi L equals to 2. So this is a condition for null deflection. Phi L equals to E. So for question number 23rd, answer is 25. Question number 24. Here we see that a concave mirror is there, and a thin cylindrical rod is kept on this principal axis. So its ends has coordinates say A and B, and C is say center of curvature. So this focal length is given as say minus 20 centimeter. So this radius will be say curvature will be say minus 40 centimeter. So for coordinate A to C will be 5 centimeter, and this is again 5 centimeter, and the center is at 40 centimeter from here. So for UA, minus 45 will be coordinate. For B point, minus 35 centimeter will be coordinate. And from this mirror formula, V is given as Fu divided by U minus F. So this image distance VA will be given by minus 20 minus 45 divided by minus 45 plus 20 centimeter, and this is nothing but minus 36 centimeter, and V will be position of image of point B. So it will be say minus 20 into minus 35 divided by minus 35 plus 20 centimeter, and it will be say minus 140 by 3 centimeter. So this length of image will be difference between these two. That is say velocity, position of B and position of A mod. That will be the length of image. So it will be say 140 by 3 minus 36. So we will take difference of magnitudes of these distances. So it will be say in centimeter, and it is say 32 by 3 centimeter, which is say x by 3 centimeter. So this x comes out 32. So its answer is say 32. Question number 24. Question number 25. For this, displacement is difference of position vectors, final and initial. So final position vector is 5 I cap minus 2j plus k cap, and we have to subtract initial position vector 2I cap plus 3j cap minus 4k cap. So it comes out 3I cap minus 5j cap plus 5k cap. This is a displacement vector. Force vector is given as 5I cap plus 2j cap plus 7k cap. So this work will be F dot S. That means 15 minus 10 plus 35, and it will be in joule. So it will be say 40 joule. So this answer will be 40. So its answer will be 40. So in question 25, small particle moves to position 5I cap minus 2j cap plus k cap from its initial position 2I cap plus 3j cap minus 4k cap under the action of force 5I cap plus 2j cap plus 7k cap Newton. The value of work done will be. So first of all, we will calculate displacement, and then we will take dot product with force vector. That will be the work done. In question number 26, a certain pressure P is applied to 1 liter of water and 2 liter of liquid separately. Water gets compressed to 0.01%, whereas the liquid gets compressed to 0.03%. The ratio of bulk modulus of water to that of the liquid is 3:x. The value of x is. So in this question, we see that we have to use bulk modulus. Bulk modulus is the pressure applied and divided by volumetric strain produced. So this delta V by V minus delta by V is the volumetric strain produced. For water, this we have to find ratio bulk modulus of water to the bulk modulus of liquid. So it will be say strain. So it will say strain produced, volumetric strain for liquid to the volumetric strain of water. This volumetric strain of liquid is given as 0.03%. It is a 0.03%, and volumetric strain of water is given as say 0.01%. So this ratio comes out 3:1, that is say 3 by x. So from here this x comes out 1. So its answer will be 1. So its answer is 1. Question number 27. A series LCR circuit is connected to an AC source of 220 volt 50 Hz. The circuit contain a resistance R equals to 100 ohm and inductor with active reactance XL equals to 79.6 ohm. The capacitance of the capacitor needed to maximize the average rate at which energy is supplied will be in what microfarad. So for this question, first of all, we will see that LCR circuit resistance is given as say 100 ohm, XL is given as 79.6 ohm, and omega is given as 2 pi f, that is say 100 pi radian per second. So we have to find XC. So we have to find XC. So for maximum power, so maximum power in LCR circuit, the circuit should be resonance. So resonance series LCR only. So series LCR, and for this reactance must be 0. That means XL minus XL must be 0. That means XL minus XC must be 0. That means XL and XC should be equal. So that's why XL is given as say 79.6 and XC is given as say 1 by omega C. So from here we can get capacitance C as 1 by 100 pi divided by 79.6 during farad. So it comes out 40 into 10 power minus 6 farad. That means 40 microfarad. So this answer will be 40. So this answer is 40. In question 28, the amplitude of a particle executing SHM is 3 centimeter. The dispersion at which its kinetic energy will be 25% more than the potential energy is how much centimeter? So we have to find displacement at which kinetic energy and potential energy are not equal. In fact, kinetic energy is 25% more than the potential energy. So kinetic energy is given by K, and that equals to say 25% more. That means it is say 125 by 100 times potential energy U. So kinetic energy is say 5 by 4 times potential energy U. So from here, if we take E as total energy, it will say kinetic plus potential energy. So it will be say 9 by 4 times potential energy. So what we get, total energy is say 9 by 4 times potential energy. Here, kinetic total energy E is equals to maximum potential energy, that is say half k square. And potential energy at a certain position is given as say half k x square. So from here we get that this amplitude square equals to 9 by 4 times x square. From here x equals to 2a by 3. So it would say 2/3 of 3 centimeter. That means 2 centimeters. So this position will be 2 centimeter. So its answer is say 2. So this question 28 answer is 2. In question 29, a solid cylinder is released from the top of inclined plane of inclination 30 degree and length 60 centimeter. If the cylinder rolls without slipping, its speed upon reaching the bottom of the inclined plane is how much meter per second? Take G equals to 10 meter per second square. So in this inclined plane, what we see that this height h, so there it will be at certain height h. So first of all, we have to find height h. So this height h will be 60 centimeter sine 30 degrees. So this height h will be say 30 centimeter. When this sphere reaches here, it will have velocity and angular speed both. It will have velocity and angular speed both. So say its velocity is say v and angular speed is omega. So from here, this velocity comes out root 2j divided by 1 plus k square by r square. So for a rolling body, velocity is where k is called radius of gyration. For this cylinder, mk square is say mr square by 2. So that means this k square by r square is half. So this velocity v will be 2gh divided by 3 by 2 root. So its value comes out 4 by 3. G is 10 and its height is 0.3. And then we have to take root and it will be said meter per second. So this velocity comes out 2 meter per second. So its answer is 2. So for this question, answer is 2 meter per second. Question number 30. A charged particle of 2 microcoulomb accelerated by a potential difference of 100 volts enters a region of uniform magnetic field of magnitude 4 millitesla at right angle to the direction of field. The charged particle completes semicircle of radius 3 centimeter inside magnetic field. The mass of the charged particle is how much into 10 to the minus 18 kg. So in this question, we have to find. So in this question, we have to find, say some charge particle Q is given as, so Q is given as say 2 microcoulomb. So this charge is given as say 2 microcoulomb. Then potential difference applied is say 100 volt. And magnetic field is 4 into 10 power minus 3 Tesla, millitesla. The charge particle completes semicircle of radius r 0.03 meter. The mass of the charge particle. So we have to find mass. So radius is given as a momentum divided by QB. This momentum is say under root 2mk. K is kinetic energy, QB. And this gain is kinetic energy is say charge into potential accelerated divided by QB. So this radius comes out. Now this radius is say under root 2mb by q and multiplied with say 1 by b. So this br. So this br equals to this. Now we have to find mass. So this mass will be say br square divided by 2m into q. Now this br is say 4 into 10 power minus 3. Radius is say 0.03 and this whole square divided by potential 2v, so 2 into 100 and then charge. So this charge is say 2 micro and that means 10 power minus 6. So this will be in kg. So this value, this mass value comes out 144 into 10 power minus 18 kg. So this unknown number, is say 144. The answer is say 144. So we have to fill 144 as option. So this is a complete 30 questions of this. So thank you.